Hamiltonian in the Gibbs measure. Kita akan go through this lattice model, then we can see what is the difference between different kind of lattice model, and we can see that they give a different Hamiltonian for the vertices. Okay, so if this Gibbs measure is compatible with this equation, okay, so according to Kolmogorov theorem, there is exists Gibbs measure for the model given by this Gibbs measure. When we construct Gibbs measure according to model that we choose, okay, then we need to prove for this equation. Okay, if this one compatible with this equation, then we can say that there is exists Gibbs measure for the model. Okay, then as I mentioned before, during the phase transition punya slide, okay, if there is exist non-uniqueness of this measure, then phase transitions will be happen. Okay, so we have a lattice model. So there are many lattice models was created in order to study this phase transition phenomena. So each model have a different kind of Hamiltonian function with a different set of spin values phi. Okay, so some examples of lattice models are Ising model, Post model, and lambda models. Okay, so dekat untuk lattice model ni, kita akan consider different kind of Hamiltonian function with different sets of spin value. So different model, we use different Hamiltonian function and different set of spin values. Then we want to see some example of this lattice model. We have Ising models, we have Post model, and we have lambda model. Okay, then we go to Ising models. Okay, so Ising model is considered as the simplest model to describe this phase transition phenomena. Okay, so configuration X vertices given by sigma X element of plus and minus. So we have configuration plus and minus. And our spin value for this Ising model is given by Z phi equal to plus 1 and minus 1. Okay, so for the Ising model, as I mentioned before, each model, the difference is in the Hamiltonian function. Okay, so for this Hamiltonian function for the Ising model, so we have negative J summation of these vertices. Okay, so we have sigma X times sigma Y. Okay, so we have a different configuration in the Kelly tree. Okay, then the interaction between the configuration in the spin values. Okay, so we will have we have multiply sigma X times sigma Y. Let us look at one example. So let us consider this case. Okay, so we have this Kelly tree. Okay, so we have Kelly tree. We have plus, plus, plus. So we have configuration plus, plus, plus. So our sigma is plus, plus, plus. Okay, so by in order to find the Hamiltonian function for this configuration, so we will have negative J time negative J time sigma X, we have plus time plus, so we will have plus 1. So we have plus 1. Okay, then we have minus J time plus 1 for this one. So we have plus 1 and plus 1, and we have plus 1 and plus 1. So plus 1, we will have plus 1 and plus 1. Kita darabkan, kita akan dapat plus 1. Okay. Dan kat sini kita ada plus and plus configuration. Dan bila kita darabkan, kita akan dapat plus. So according to Hamiltonian for this Ising model, so we will have negative J minus negative J, which is equal to negative 2J. So that's how Ising model work. Okay, in for the Ising model, it is considered as the simplest model to consider for this factorization in the Kelly tree. Because as we know, for the particle in the metals, we have plus and minus. That's why Ising model considered as the simplest model, since we have plus and minus. Then the iteration is simple. When we have the interaction between the configuration is multiply each other. Okay. Then we have a pause model. Then for the pause model are known as a generalization of Ising model. Okay. Compared to the Ising model, okay, we can have any configurations and spin values for this model given by this delta function. So we have delta function configuration of x, configuration of y. So if configuration of x not equal to configuration of y, we put it as 0. When we have configuration x equal to configuration y, so we have 1. So we have the Hamiltonian function for pause model given by this Hamiltonian function. So compared to Ising model, so interaction between sigma x and sigma y, so we have multiply with each other. But for pause model, so we have interaction between sigma x and sigma y in terms of delta function. When we have a different sigma x and sigma y, so we have value 0. And when we have the same value of sigma x and sigma y, then we have value 1. So let us look at this example. So we consider the same Kelly tree. So we have the same configuration plus. Okay. So we use Hamiltonian with the delta function. So we plug in our configuration in the function of Hamiltonian. So we have plus and plus. In this case, we have, since we have the same configuration of sigma x and sigma y. So in this case, we have 1. Same goes to this one. We have plus and plus, and then in this case we have 1. And so for this one we have negative j minus j, then we have negative 2j. So for the pause model, they consider a function. Instead of as a model, they choose multiply as the interaction between the configuration. Okay. Then let us move on to our next lattice model. So we have a lambda model. Okay. So the idea of the lambda model is to have a lambda function in our Hamiltonian function. So we can choose any function for the lambda model. Okay. Compared to pause model, if we have this interaction, so we have 0 and 1. Okay, but for lambda model, the idea is to have any function. We can choose any function for the lambda model. For example, for this case, okay, for the sake of simplicity, so we use configuration sigma x as eta 1, eta 2, and eta 3. Okay, so this one is our configuration. So we have eta 1, eta 2, and eta 3. So this one is the Hamiltonian function for the lambda models. Okay, so in this case, as you can see, compared to Ising model and the pause model, we use lambda function here. So we have lambda function. Where when we have lambda function, we have two configurations, eta I and eta j. When we have the difference between I and j is 2, so we have A. Then when we have the difference between I and j, the difference is 1, we have B. Then when we have different I and j, and when we have I equal to j, then we have C. So as we can compare with postmodel, so we have 0 and 1. But in this case, we put as A, B, and C. So this A, B, and C can be any number. So the idea of lambda model is you can choose any model. You can choose any function for this lambda. For example, you want to put as log, you want to put as x plus y, it's up to you. So the idea. So for the lambda model, we use configuration with these three values spin. So we have eta 1, eta 2, and eta 3. Okay, so let us consider these cases for the post model for this Kelly tree. So we have eta 1, eta 1, eta 1 here. Okay, so for our Hamiltonian, okay, so we have delta lambda function. So we have eta 1 and eta 1. So eta 1 and eta 1 is the same. So we have eta 1 and eta 1 is the same. So we have C plus lambda eta 1 and eta 1. So we have eta 1, eta 1. So we have plus C. So in this case, the Hamiltonian for this lambda model is 2C. Okay. So noted that lambda model can be reduced to post model by setting A equal to B. Okay. So as we can see from this lambda function, okay. Okay, if we set A equal to B, which is we have a different I and J, so this one we can have A equal to B. So this one we can have a post model with B equal to 1, B equal to 0, C equal to 1. So frankly speaking, we can say that lambda model is generalization of the post model. Okay, so that's all for my presentation for today.
Okay, terima kasih Dr. Mohd Hakim.
Yes,
Sekarang sesi soal jawab. Saya buka untuk para pensyarah bertanya soalan atau mohon pencerahan. Dipersilakan kepada peserta yang mengikuti Kolokium ini melalui saluran YouTube. Boleh bertanya soalan melalui chatting box. Penjaga bertugas akan membantu untuk menyampaikan soalan tersebut. Dipersilakan.
Assalamualaikum.
Waalaikumsalam.
Thank you, Dr. Agus and Dr. Mohd Hakim. I just want to ask a general question because this is not my area. Okay, based on your knowledge, in which direction your work can be extended? Maybe from your PhD? That's all, thank you.
Okay, terima kasih kerana atas pertanyaan. Okay, so untuk bahagian using lattice model for the phase transition, so sentiasa kita mencari the best model, not to say the best model, so the most general model for this phase transition. So ada banyak cabang sebenarnya untuk bahagian ni. So for example, okay, for the Ising model, okay, for the Ising model, so sebelum ni saya explain pasal iteration between this one and this one. So we have they call this one as a nearest neighbor between the vertices. So dekat sini researcher try go for a complicated one. For example, they go for K equal to 3. So in this case, we have edges yang lebih lagi compared to this one. So different edges can give more complex thing to solve actually. Okay, and there is some research they start to consider this interaction. Okay, so they call this interaction as one level interaction. Okay, so they said that for the interaction, okay, so compared to nearest neighbor punya interaction, okay, so this one level interaction is a little bit weaker than compared to this interaction. The direction of this research, they try to go for generalization for this model, okay, in order to study this phase relation. We try our best to at least to describe this phenomena, this phase relation phenomena. Yes.
Okay, thank you, Dr. Hakim.
Okay, welcome.
Okay, terima kasih Dr. Hakim, terima kasih Dr. Hanimah. Ada soalan lain dipersilakan untuk bertanya? Ya, Dr. Rini, ada soalan?
Tak dengar.
Dr. Rini tak dengar suara Dr.
Sorry,
Rini.
I mute. Sorry.
Okay,
I mute.
mohon
I have 3 questions actually because this is involve some pure maths and I would like to understand the elements in the set of the Kelly tree. So let's say in the Kelly tree, K is equal to 2. Okay, can you be 2?
Yeah.
So you have 3 edges, right?
Yes.
And then the next slide after Kelly tree, there is a set, right? The next slide. Sorry. Okay, that slide. Yeah.
Okay.
Okay. If K is equal to 2, you have 3 edges. So can you tell me the from the Kelly tree the set of X there? The set, the elements. What are the elements in the set?
Okay. So, thank you, Dr. Rini, for asking the question. Okay. So, in order to answer the Dr. Rini's question, okay. For example, we choose for K equal to 2. So in this case, we have vertices. We have 3 vertices. Since we have 4 infinite Kelly tree, so we have K plus 1. So we have 3. So in this case, so we have for this K equal to 3. Okay. We have these vertices. We have vertices 1, vertices 2, and vertices 3. Okay. So dekat sini sebenarnya I tak explain. Okay. So we have interaction for this one from X0 to this one with the edges. We call it as a nearest neighbor interaction. Okay. So normally people will consider nearest neighbors punya competing nearest neighbor punya interaction. Okay. So in case for K equal to 2, okay, so this one is the set of vertices. This one for the nearest neighbor.
So only level 1.
So for only level 1. Okay.
Okay. And then what is J actually?
J just actually when we consider for example for this one as I mentioned before, from this point to these vertices, we call it as a nearest neighbor. So this one is interaction between X0 and these vertices. Okay, so they call it as nearest neighbor. Okay, then if you go to this interaction between this one, as I mentioned before, they call it as one level interaction. okay, or they call it also as a competing interaction, okay. In order to differentiate between this interaction and this interaction, so they use J. Maybe they will use J1, so interaction between this one is J2 or JP. So that's why they put J.
Okay, and then in Ising model,
Yeah.
Ising model, so I can see the branch, the
Yeah,
straight
this
line,
one,
you put positive. So how
Yeah.
do you actually construct that plus, sebab you ada minus juga kan? So kenapa you put plus plus plus? Kau also just example.
Just for example.
I see.
So we have also plus and minus for configuration.
Is it really constructed or is it just for the sake of example? You can construct, it must be plus plus plus, or there's a condition for plus minus plus or minus minus minus.
So as we can see from here, so this one Hamiltonian is collection, summation kan. So we have sigma kan. So we have plus plus plus, then we have plus plus minus, so we have plus minus plus, so we have plus minus minus. So we have many configuration, at least for this case, betul? Okay, so we have summation of all these configuration for the Hamiltonian. So I just give some example for this one for this configuration. So it's possible to have plus, minus, plus. So we have plus, plus, plus. So we can have plus, minus, minus. Or you can start from this one minus, then we have plus, plus. Each of this one give a different Hamiltonian lah.
Okay. Since you say it's infinite tree, so
Yes.
actually to what extent do you have already construct?
Okay, so actually, so why we need to prove for this one, actually? Okay, so in this case, in this part, okay, so when we construct the Gibbs measure, for example, I choose for Ising model. Okay, when we construct this measure for the Ising model, okay, so the difference is the Hamiltonian, right?
Yes.
Okay, then we need to prove for the computability for this equation. So what does it mean by this equation? Okay, so we want to prove from the considered model. So from one measure that we consider, for example, I choose this tree. Okay, at least for this tree, we construct the Gibbs measure for this tree. Okay, then we need to prove for this one. Okay, so what does it mean by this one? So we want to say that if we prove for this equation, we can say that this one can be happen to infinite punya tree. So what will happen in this tree for this one can be happen to others also.
Okay.
Clear tak? We prove for this one, then we try to check for this condition. Okay, then we can say that from this one we can also get this one for this one and for this one until to infinity. So we go from macroscopic from the things that from little to the infinity. So from this part we need some proof lah for this one.
Okay,
Check for the computability for this one.
So the Gibbs measure is actually the implication of the Hamiltonian function lah.
Yes.
Okay, faham? Okay, that's all. Thank you, Hakim.
Okay, thank you.
Okay, terima kasih Dr. Hakim. Terima kasih Dr. Rini. Okay, any more question, please? Soalan lain daripada kawan-kawan? Daud, ada soalan ke? Baiklah, Dr. Hakim, benda ni
Yes,
kita boleh apply kat mana ni?
Actually for this model, they just want to describe this phase transition punya fenomena currently. Okay, now in Uzbekistan, okay, they start to implement this lattice model in biology. They try to implement this model for the biology. So actually ala-alang kan, ala-alang kan semua ada kat sini, okay. So in this July, okay, kita akan menerima lawatan daripada auditor luar, examiner luar untuk FSKM. Lawatan daripada Prof Farouk lah, Prof Farouk Mukhamedov. Okay, so sepanjang kelawatan dia melawat ke sini, so kita FSKM akan mengadakan satu workshop. Berkenaan dengan dynamical system lah. So dia akan explain pasal dynamical system and application in biology. So ala-alang ni saya promote sekali lah. So untuk better explanation, maksudnya kita boleh by joining this workshop, kita boleh tengok yang latest model ni di start dah untuk implement to others, other area in biology. So for this workshop is more on biology. Yeah.
Okay, terima kasih Dr. Hakim untuk dengar dia dulu.
Yes.
Okay, ada lagi ke pensyarah-pensyarah yang ingin bertanya? Dari cawangan nampaknya tak ada. Okay, jika tiada apa-apa isu untuk dibangkitkan, kita tangguhkan Kolokium kali ini dengan surah Al-As dan tasbih kafarah. Sekian, wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih semua.
Waalaikumsalam. Terima kasih semua. Assalamualaikum.
Salam.